So I wanted to make a video that completely covers update order. So I'm going to start with block updates. Block updates occur whenever something changes in the world. So if a block gets placed or a redstone line gets powered, that will create block updates. That will update blocks. And it needs to in order for those blocks to realize that they're powered or that something's changed, so that they can respond to that. So for example, if I press this button, that will power this block and it will generate block updates to all of these command blocks, which will realize that they're powered and they will execute their commands. In this case, just say commands, which say their position relative to the block they're around. So the order in which these happen determines the order in which these command blocks execute their commands. So block updates get processed negative to positive, X, Y, Z. Quite easy to remember. Let's see it in practice. If I press this button, we get a bunch of output. So you can see that negative X got processed first, then positive X, then negative Y, then positive Y, then negative Z, and then positive Z, but there's a button there, so I can't put a command block there. So negative to positive, X, Y, Z. Nice and easy to remember. There's also a second type of update, which is very similar to block updates, but it gets sent out a bit more frequently. So just to demonstrate this, I'm going to use a butted piston. If I put a fence gate there and I put a redstone block above it, the piston is powered through quasi-connectivity, but it doesn't realize it's powered until it gets a block update. So if I trigger this fence gate, it doesn't provide a block update because this state change of a fence gate doesn't send out any block updates. If I break it, it does, and the piston extends. But a fence gate will send out a block shape change event. So you can see that this observer detects it, and that's because observers detect shape updates. Now, shape updates are sent out after block updates, which is a very useful fact that we can use later on. And they also have a slightly different update order. They still go negative to positive, but instead of going X, Y, Z, they go X, Z, Y. So as you can see, minus X, minus Z, plus Z, but there's no space for a block there. Minus Y, plus Y. So this is actually good because this means that it's slightly less directional. As long as you don't depend on the order of triggering between two horizontal directions, your contraption is not directional. So we can use what we've learned as well as one extra new thing to build this. This is a very simple and very short instant dropper line. So the extra thing that's used here is the fact that block updates are processed recursively. So what this means is that rather than processing all of the updates at this rail and then moving on to this rail and processing its updates and then moving on to this rail, it kind of goes immediately onto this rail. So as soon as this rail gets updated by this rail, when it's powered, it will start updating and it will pause this rail's updates. And then it will update this rail at some point and it will pause this rail's updates until it goes all the way down the line and then comes all the way back. So this, combined with the fact that shape change updates are triggered after block updates, means that we can create this completely non-directional instant dropper line. So the rails update the other rails and the updates go all the way down to the end here. And once this is finished block updates, it starts doing shape updates and it updates this observer, which powers this dropper, which has some levers in it. And this dropper puts one lever into this dropper, and because the dropper is a solid block, it also powers this dropper, updates it, and so this dropper drops an item into this dropper. So then that happens 2 ticks later, of course, because observers have 2 game ticks of delay. But the updates trickle back through this rail line, and then this one finishes its block updates, and it does shape updates and updates this observer, and so on. And so what that means is that we get a reliable update order of this observer, then this one, then this, then this, then this. And so we can use that to create this instant dropper line. So the next type of update order I want to talk about is tile ticks. So tile ticks are used to create delay in the game. Repeaters use them, comparators use them, observers use them, also redstone torches, and a few other blocks. But these are the most interesting ones. And tile ticks can have different priorities. So tile ticks with the same priority get executed just in the order they're created. But tile ticks with a lower priority than another will be executed first. So repeaters have a priority of -1, which means that they are executed before blocks with a priority of 0, like comparators and observers. So comparators and observers get updated with respect to one another in the same order that they are powered. So if the observer is powered before the comparator, it'll be updated first. If the comparator is powered before the observer, it'll be updated first. It just depends on the update order of what's powering it. But repeaters always activate before comparators if they're powered in the same tick. So this is very useful, for example, to create a 0 tick. You can have a block that gets powered by a repeater, which means that it's powered for a short amount of time, and then the comparator powers the piston, which then moves the block out of the way and depowers this piston. So if we just put a entity there, the block will teleport into the entity, which proves that this is a 0 tick. Now, repeaters have some strange behavior when they are powered by comparators or other repeaters. Their priority changes from -1 to -3. So this doesn't happen when it's through a block, but it does happen when it's directly. So in this case, this repeater has priority -1. This repeater is being directly powered by another repeater, so it has priority -3. Again, with this one, it has priority -3 because it's being directly powered by a comparator, but the comparator has priority 0. And then here, both of these repeaters have priority -1. So what that means is that we'll end up with this repeater triggering, or these 2 repeaters triggering first. The order is locational and directional because redstone dust is very unpredictable with its update order. So one of these activates first. We can basically treat them as activating at the same time, or activating in random order. So then a tile tick gets scheduled for these, and this comparator also schedules a tile tick, but it's priority 0. So these repeaters get activated first. They're tile ticks, so they power these repeaters. This one has priority -3. So its tile tick is going to get updated, it is going to get executed before this repeater's tile tick, which has priority -1. So then this comparator gets its tile tick executed, which powers this repeater, which has a tile tick priority of -3, but the tile tick was created after this repeater's tile tick, so it will be executed afterwards. So because this repeater's tile tick priority is only -3, the command blocks will be executed in this order: 1, 2, 3. So let's see if that's the case. Repeater, repeater, comparator, repeater, repeater, block, computer. Yep. Next up, I want to talk about slime or piston update order. So pistons, when moving slime block structures, update the blocks in a specific order, and that order is in columns facing the same way as the piston, from the furthest away to the closest, but ties are resolved with reverse block update order. So in this case, this block is the furthest column away. It's 1, 2, 3, whereas all the rest are 2 or less. And so this block will get moved first. Now, the order in which columns are moved depends on whether the piston is extending or retracting, because if it's extending, this block needs to be moved before this block is moved so that there's space for this block to move into. So if it's extending, it gets updated from the end to, so from furthest to nearest to the piston. If it's retracting, it's the opposite, so it gets updated from closest to furthest from the piston. So because ties are resolved with reverse update order, things in positive x get moved first, then negative x, then positive y, positive z, negative z. So in this case, this is positive x here, so this block will get moved before this block. So the order will be this block, then this block, then this block, then this block. So the command blocks will be executed in this order. That one, and then this one, then this one, and then this one. So if we push that, we can see that's correct. We get the furthest, then plus x, minus x, then center. Now for retracting, it's going to be the same, but bear in mind that if we had another redstone block somewhere in this structure, it would get moved in a different order depending on whether it's extending or retracting. So the last thing I'm going to talk about is block events. Block events are used by pistons to schedule their retraction and extension. So when you power a piston, it doesn't immediately start extending. It schedules a block event to start extending and then extends when that block event is run. Now, block events are executed in the same order that they're created. There's no priority or update order here. So if you power 2 pistons in the same tick in a certain order, they will be pushed in that order. But what gets interesting is when you start triggering block events with other block events, because this circuit here, if we place a redstone block in here, it's going to directly power this piston, quasi-power this piston, and this piston. But what's interesting is that when this piston is directly powered, it schedules a block event, and when that block event is executed, it updates this piston, which then schedules a block event. When that block event is executed, it updates this piston, which then schedules a block event, and then when that block event is executed, it starts extending. So what happens is that we get 1, 2, 3 block events of delay, or, well, actually 2 block events of delay before this block event starts. So we can see that the order is consistent here. A, B, C. And that's because this piston always extends first, then that updates this piston to extend, that updates this one, which makes it extend. So that's pretty much all I wanted to talk about. I hope someone found this helpful. I'm planning on putting out some other videos on more interesting or obscure game mechanics soon, so stay tuned. Thanks for watching.